This is an interesting graphing problem in which we're asked to find the function which produced the graph. And we've done this before, right? This is not the first time we've done one of these style problems. However, there is something that's new about this one. Do you see this point right here? If you remember the concept of bouncing and crossing when you're at the x-axis, this gets back to multiplicity of a polynomial. So we're kind of mixing together some old terms with graphing polynomials with the new stuff we're learning in graphing rationals. We'll get to this in a moment, but just recognize that we've got a bounce going on here, so we need to deal with that at some point. Now, when I make a rational function to match a graph, remember where the pieces of the rational function come from. I have vertical asymptotes on bottom, but they don't go on top. I have x-intercepts on top, but they don't go on the bottom. And if there's a hole in the function, that has to be on both the top and bottom. Okay, so let's identify portions of this graph and put them in the appropriate places. I see here there's an x-intercept, not an x-intercept, a vertical asymptote at x equals 1 and at x equals 6. So what that means is x minus 1 and x minus 6. Okay, let's swap colors, move to something else. Take a look at the x-intercept. That's in blue. That's at x equals 3. So that has to be coming from a factor of x minus 3. And not only that, it's a bounce. Okay, that means multiplicity of 2. Do you remember what multiplicity means? Multiplicity equals 2. Multiplicity is the exponent that's over the factor. So I have a factor of x minus 3 squared because it's bouncing at x equals 3. Okay, and now let's move on to something else. I think this hole right here looks very interesting. See that guy right there at x equals 5? That's going to be a factor of x minus 5 on top and, whoa, hold on, and on bottom. Okay, so this is a great first guess at our function, but we're not done yet, because what we have to do is we have to recognize that f of x is going to be very close to this, but we might be off by a little bit. And the amount we're off by is the old idea of the scaling factor. Remember the scaling factor? We've calculated it before. It's just some number that goes in front. It's not an x. It's very important. That's never an x in front. It's always just some number. Could be a fraction, could be a negative, could be the number 1 if we're lucky. But let's figure out what that is by looking at this y-intercept right here. So if I say f of 0 equals b times negative 3 squared, negative 5, remember I'm setting all the x's equal to 0 to find the y-intercept, negative 1, negative 6, and negative 5. Okay, well, let's see what happens now. I'm just going to keep this in green. So f of 0 equals, well, those negative 5's cancel out, and on top it's just 9b over 6. 9b over 6 equals negative 3. The reason it equals negative 3 is because that's the y-intercept. Okay, so let's solve this equation. That means 9b equals negative 3 times 6, which means b equals negative 18. That was the result there, divided by 9, which is negative 2. Okay, let's write the full equation now. I think we have all the pieces we need. F of x equals negative 2 was my scaling factor, times x minus 3, that was the x-intercept, which bounced because it had a multiplicity of 2. X minus 5 is part of the whole, and you see that x minus 5 on the bottom as well. And we have x minus 1 and x minus 6. Okay, that's your full equation, and hopefully you can see where all those pieces came from as we were doing this.